Imagine Goldman Sachs asks you this in an interview. You have five tasks, and each task needs some minimum energy, right? Minimum energy to start it. Now, each task needs some energy to minimum energy to start with, and but after doing it, you gain some energy. Now, and they ask you, what is the minimum initial energy needed to finish all the five tasks? All tasks need initial minimum energy, right? We need the initial minimum energy. So the problem is simple. What is the minimum initial energy needed to finish all tasks? Now, most people start panicking because this problem looks like a DP problem. Now, feels like a binary search and smells like a greedy. What if I say it can be solved in a simple sorting trick? Now, let me tell you how we can understand this problem first. Now, imagine we have actual and minimum for every task. That's not given in the problem itself. Now, actual is the energy spent doing the task, right? Now, to start this task, need some energy. We need some minimum energy. Minimum energy needed to start this task. Just to start this task, right? Now, let me tell you, if I have 10 comma 12, I need the energy of 12 to start and 10 will be drained. 10 energy will be drained. That's it. That's so simple, right? Now the main question will goes like, so the real question will become, what order should you perform task, right? So that our starting energy is minimized. What order should we start? Should we start so that our starting or initial energy is minimized. I need an order, right? Let me take a real world example. Now, every programmer instinct is they think like this is a hard problem and also cannot be solved. But let me tell you one thing, one thing. We can go like the hard task first. We'll go like hard task first. Just go with the one which is having the maximum required minimum energy, right? Which is having maximum, or just sort it in descending order. But that's so wrong. That's so wrong. Let me tell you why. Let me tell you why. Now, let me say, now every programmer will go with that descending order. But let's look carefully. Imagine I have 1 comma 100. Now, this task only consumes one energy, right? But demands 100 energy, 100 just to start. Now, how can we go further? Is this task is basically that one friend who says I'm outside bro or while still bathing and I will be there in 5 minutes, right? When we ask for them to come out. Now, the problem is not about which task consumes the most. The problem is minimum minus actual, right? What is the minimum, but what is actually consuming or draining the energy? Because this value tells us how much fake pressure this task creates. How much fake pressure, fake pressure this task creates. So we will not go with minimum or actual, but instead we'll go with sorting it in minimum minus actual. Let me take an example so that you can understand it betterly. All right? Let me take this 1 comma 3, 2 comma 4. 10 comma 11, 10 comma 12, and then 8 comma 9, right? Now, I said minimum minus actual. This works because I am draining draining the initial amount in a way nothing but the minimum minus the actual. That's it, right? This is the energy that is drained, right? This is the energy that needs to be have kept in the initial amount. Let me tell you how it works. 1 comma 3, what is the difference? 2. I'm just writing the difference. 2 comma 4, what is the difference? 2. 10 comma 11, what is the difference? 1. 10 comma 12, what is the difference? 2. 8 comma 9, what's the difference? 1. I'll just sort it in descending order 2, 2, 2, and then 1, 1. So I'll get it as 1 comma 3 and then 2 comma 4 and then 10 comma 12 and then 10 comma 11 and then 8 comma 9. That's it, right? Now, how can I solve this? Imagine I have the actual amount is lesser than the minimum amount. The energy I have initially, the energy I have initially is 0. Now I need 3, right? So I will add 3 here. Now 3 minus 1, which is 2, right? Now 2 will be our energy. Now from 2 and 4, here if you see the actual minimum energy I need is 4, right? But I have 2, right? So what is the amount which I need to add? Plus 2. Now 2 plus 2 will be our energy. So our energy is 4. Minus 2. If I remove the actual amount needed, actual energy needed, 4 minus 2 will be 2. Now the energy again made as 2, right? Now I need 12 as the minimum energy, but I only have 2. So 2 plus 10 will be 12. 12 minus 10 will be 2. Again, our energy has become 2. Now, 2 and 11. I need 11, but I only have 2. So 2 plus 9 will be 11. From 2 plus 9 will be 11. 11 minus 10. The action needed will be subtract. 11 minus 10 will be 1. So I am changing the energy to 1. Now, I need 9, but I only have 1. So 1 plus 8 will be 9. And if I get the total energy is 9, 9 minus 8 will be 1. But if you see, but if you see, I started with 0. I added 3, I added 2, I added 10, I added 9, then 8. If I add all these, I would get 3 plus 2 plus 10 plus 9 plus 8. Let us check. 8 and 2, 10, and then 10, 9 plus 3, 12 will be 32. 32 is the minimum amount that needed. So, first sort minimum minus actual, right? Sort in descending order. Then what I need to do is initialize the energy as 0 and the amount as 0 and go with the for loop for every task. And if the energy is lesser than the minimum, right? So minimum will be task of 1, amount will be task of 0, right? If energy is lesser than minimum, extra needed will be minimum minus energy. Now I will add this extra needed to my answer. Answer plus is equal to extra needed. Then I'll change energy will be the minimum amount, right? Then we'll return the answer at the end. So that's how we solve this problem, and I have given the code link in the description. Go and check it, and thanks for watching this video. Please do like, share, and subscribe to my channel.